I'm Thomas Gontier from IDELE, the French Livestock Institute. And the webinar is part of the Climate Smart Advisor program with European funding. And on this program, I am the thematic leader on biogas production. So I'm very pleased to welcome all of you. 150 of you were registered. So we will see there's more people from 24 countries, and you are just a little more than 40 connected. The webinar will be registered, and it will be available on the YouTube page from the other program, Climate Farm Demo, another program funded by the European Union. And I will give you the link in the chat at the end of the webinar. For this webinar, we welcome Florent Levasseur from INRAE. I will let him introduce before his presentation, and Florence Benoit Florence Bedouin, sorry, from IDELE, was here to help me at the end for the questions. The presentation will be followed by a question and answer session. And for this session, you can ask your question on the chat. We'll choose the question at the end to ask to Florent. What else? Yeah, I have some notes. So yes, we are together just for around an hour with Florent's presentation and the question and answer session at the end, and at the end a satisfaction poll. So the first slide with how to use Click Meeting. All this information stay in the chat, so you can find them during the presentation if you have some questions. So just about the browser, some problem, you can also connect with the phone if you have some problems. So display to put it on full screen. So the chat, if you have any question during the presentation, please write the question in the chat. The chat is moderated and question will be asked at the end. And the presentation is recording, and you will have access to the presentation on the YouTube page. So now about Digestate. I'm thematic leader from biogas production in Climate Smart Advisors, and I'm regularly asked on biogas production, not on the how does it work, but mainly on all the question, mainly feed, food, and energy competitions. Also about carbon reduction with biogas plant on farms, and the question about the impact on soil. So now, Florent, you can make your presentation, and I'll let you introduce yourself.
Okay, thank you, Thomas. So I'm Florent Levasseur, so I'm researcher in INRAE in Palaiseau. Yeah, it's near Paris. My research topic is about the recycling of organic waste in agriculture, and so since a few years now, I have conducted some different projects about Digestate. Yeah. So today, just as a short introduction, just to remember what is a biogas plant. So we have a production of energy from the anaerobic digestion of organic waste or products, and of course the production of a digestate that contains the residual organic matter and the nutrients, and which is used as a fertilizer. Yeah. In a biogas plant, it can be fed by different substrates. So here you have the mean feedstock of biogas plant in France last year. So you can see that at the moment the livestock effluent are still the main feedstock of biogas plant in France, even if energy cover crop in green are developing a lot in the last year, and you have also a lot of agro-industrial waste and food waste now in biogas plant. But livestock effluent are still the main input in this biogas plant. Yeah, so it's a different situation than in other countries like Germany, where the part of dedicated crop in France in dark green is limited by the regulation. Yeah. What happened in a biogas plant? So just briefly, we have a transformation of organic matter. So typically, the recalcitrant organic matter is not very decomposed or mineralized during the digestion, but it's mainly the labile organic matter that is mineralized. So at the end, in the digestate, this recalcitrant organic matter is still present with microbial biomass and part of labile organic matter that has not been mineralized, and the carbon that has been mineralized is exported as biogas, so a mix of CO2 and methane. Yeah? And concerning nitrogen, so usually in the input you can have already some mineral nitrogen, like in pig slurry or in slurry generally. But this a part of organic nitrogen is also mineralized during the digestion. So at the end, in the digestate, usually you have more mineral nitrogen than before digestion. Yeah? But you have for the nutrient, nitrogen, phosphorus, and potash, the digestion is conservative. So you have the same amount at the end, but just the form can be modified by the digestion. Yeah? And this mineralization also depend on the type of substrate. So here you have just some example of how much of the carbon is mineralized during digestion. So you can see that for maize silage, for example, around 80% of the carbon can be mineralized, whereas for more recalcitrant substrate like cattle manure, it's only around 40%. Yeah. For nitrogen, the part of nitrogen that is mineralized during the digestion vary also between the different substrates. And after the digestion, in many cases, but not always, you can have a fast separation of the digestate that result in the production of a liquid phase, the liquid digestate, and a solid digestate. Yeah? And at the end, even if the digestion is conservative for nitrogen, you can have some loss, especially during digestate storage, especially if it is not covered, the storage, and you can have some loss of nitrogen as ammonia, especially. So this transformation result in digestate that have variable characteristic depending on the biomass digestate and the considered fraction, raw, liquid, or solid digestate. So yeah, I just give some few example of carbon, nitrogen, mineral nitrogen, and phosphorus content of different digestate in blue. So two raw or liquid phase of digestate from one from pig slurry, mainly from pig slurry, and the other from cow manure and pig slurry, and a solid phase from mixed origin. And you can see that the content in terms of carbon, for example, for the raw or liquid phase are similar to that of a pig slurry in red, whereas for a solid phase it's more similar to a compost, and so on. So just I'm not going to detail this figure, but just to show that the content in terms of carbon or nutrient content are similar to more usual organic fertilizer. Yeah? And if you consider the usual rate of at which farmers use digestate, at least in France it's some common rate. So for around 30 cubic meters per hectare of raw or liquid digestate, 10 tons per hectare of solid digestate, you can see the input in terms of carbon or nutrient per hectares, compare again to compost or slurry. So you can see that, and I have had in yellow, the small line is the export of a wheat crop, both with grain and straw export. So you can see that the application of digestate at a usual rate could compensate the export, for example, of nitrogen, phosphorus, or potash, even if it's not as simple because all the nitrogen is not available. I will discuss that later. And but for carbon on the right, you can see the yellow line is the amount of carbon exported by wheat straw. And you can see the carbon input by digestate. So you can see that for carbon, the input of carbon are limited because for liquid phase and raw digestate at least, because it doesn't compensate the export of wheat straw. Yeah? So just this figure to have some figure in mind about the input flux of what correspond the digestate application. So just now, so you can see that digestate contain organic matter, nutrients, and contaminants. So like other organic fertilizer, they can potentially increase soil organic matter. They can have some effect on soil biological and physical properties. They can, of course, replace mineral fertilizer with the nutrient they contain. These nutrients are also subject to loss. We can have also some contamination of soil and crop with the contaminant they contain, like with fertilizer. And all this effect, of course, depend on digestate characteristic and cropping practice, so typically the rate and period they are used. Yeah? So I will detail a bit each of these points now. Yeah. So I start with the organic matter, the effect of digestate on organic matter, soil organic matter. So the anaerobic digestion, it increases the stability of the residual organic matter in the digestate. So here you have a figure of Thomson that show the carbon mineralization in controlled condition in lab. Of a feed compared to a digested feed or feces, so a feed that has been fed to a cow or to the digested feces, and you can see that the digestion decreases the carbon mineralization. Yeah, so the stability of the digestate is higher than the undigested biomass. Yeah? So just like for the effect of composting. Yeah? So we have less carbon at the end, but this carbon is more stable. And if you compare this potential of carbon mineralization in controlled condition to other organic fertilizer, you can see on this figure the box plot for digestate. It is quite variable. So it range between 20 to 40%. So yeah, it's in milligram per gram. So it's 20 to 40% of carbon is mineralized, usually in this lab incubation. So it's similar or slightly lower than the manures. It's higher than compost. You can see here the compost in brown. It's more stable. Potential of mineralization is lower, but digestate are more stable than over fertilizer like sewage sludge in pink or vinasse in gray. So we have a loss of carbon in the biogas plant because we export methane and CO2. So with the digestion of with an aerobic digestion, you have less organic matter returned to the soil, but we have an increased stability of this organic matter. So what is the resulting effect in terms of soil organic matter? So different studies have shown that without the introduction of more biomass in the biogas plant, usually the effect of anaerobic digestion is to decrease slightly the soil organic matter, or it is almost stable. But yeah, most of the studies show that there is a slight decrease. So here, just an example. For example, it's the carbon storage after 20 years. So in case of raw cattle manure, so it's compared to raw cattle manure. So for raw cattle manure after 20 years, it's zero, the difference. But for digested cattle manure, you can see a slight decrease in carbon stock. But in very often, when farmers set up a biogas plant, they introduce more biomass in their biogas plant. So it can be, for example, food waste or agro-industrial waste. And also, like in France at the moment, with the development of energy cover crop, farmers produce more biomass in their field to feed the biogas plant. So finally, more biomass enter the biogas plant, and at the end, it results in an increase in soil organic matter. If we compare the effect of anaerobic digestion to other way to use biomass, it's a very recent study that has compared different way of using biomass. So if you take the same amount of initial carbon from a crop, so if you apply it directly to the soil, 100 whatever, it can be tons of whatever the unit at the end. The soil storage efficiency, you have 16 unit of carbon stored in the soil. Yeah? And you can see that if you compare to use this crop biomass to feed a cow or for anaerobic digestion, for composting or for pyrolysis, the anaerobic digestion is the least efficient for carbon storage. So compared to previous study, the hypotheses are less favorable. So that's why maybe in this study it results in a higher decrease in soil carbon than the other study. Now, if we, in terms of soil organic nitrogen, inorganic nitrogen, the organic nitrogen of digestate is rather stable. You can see it's also some result of lab incubation of digestate of cover crop here. You can see that the mineralization is very low. And again, if you compare it to other organic fertilizers, so here in blue you have a digestate, you can see that it's centered on zero. So some digestate promote nitrogen immobilization when the mineralization is negative, or other promote a slight net nitrogen mineralization. But globally, the mineralization of digestate is organic nitrogen of digestate is limited compared to, for example, chicken droppings in green or sewage flood or vinasse. So the nitrogen fertilizer value is mainly related to the mineral nitrogen they contain. In the short term, the organic nitrogen does not supply a lot of mineral nitrogen to the crop. Yeah. So it results in a good fertilizer value, even if this organic nitrogen is rather stable, because a big part of nitrogen in digestate is mineral. So you can see on this figure, it's the mineral nitrogen fertilizer equivalent of various organic fertilizer. And you can see that for biogas digestate, it's around 50 to 70%. So it's higher than slurry, manure, compost, and so on. And so, but it's lower than 100%, of course. So it means that 1 kilogram of nitrogen from digestate usually is less efficient than mineral nitrogen. But compared to other organic fertilizer, it's some good nitrogen fertilizer if it is used when at the good moment, at the good rate, when the crop need nitrogen, of course, to limit nitrogen losses. So thanks to this good nitrogen value, we can have farmers can save mineral nitrogen. when using digestate, and but some more studies, here it's a modeling study that has tests for typical crop livestock farm, the use of the decrease in the use of mineral nitrogen according to the proportion of to the amount of nitrogen import in their biogas plant with other waste. So typically a livestock farm that would use only his manure as a feedstock for his biogas plant, you can see that the decrease in mineral nitrogen use is very limited. So because it's the consequence of there is a small part of the organic nitrogen that is mineralized, and so thanks to that, it's more the manure, digested manure is more efficient, so it allows a small saving in mineral nitrogen, but most of the saving are realized when the farmers import some external waste in his biogas plant. Yeah. Yeah. That. So you can save, farmers can save nitrogen with when using digestate, but to do that, it's also important to limit nitrogen loss. So an important loss for digestate can be ammonia volatilization. So it's a loss for farmers, but it has also a big impact on air quality. And some studies, there are contrasting results in the literature about the volatilization of digestate. It depends a lot on the dry matter content on the digestate, of its pH, of the part of nitrogen mineralized during digestion, and to what it is compared. If you compare it to a raw slurry, if you compare it to a mineral fertilizer. But usually it is an important loss to limit. So typically by using trailing hose or injection to apply digestate, to apply it with a good weather condition, and also fast separation can help because typically most of the mineral nitrogen is in the liquid phase, and in that with fast separation, the liquid phase better infiltrate into the soil, and so it can limit ammonia volatilization. Yeah. But to just to show an example of volatilization, to show it can be a big issue. Here we have it's an experiment we have in Western France, where we compare 4 fertilization system with either mineral nitrogen, raw manure, digested manure, or digested manure with phase separation. So with the application of both liquid and solid digestate. Here you can see the figure accumulated for 3 years, and you can see that with raw digestate, you have the most of ammonia volatilization, and it can be up to 150 kilograms of nitrogen per hectare. So it's very big nitrogen loss, and you can see the emission factor that is higher for raw digestate. So it can really be a big issue here. Concerning nitrate leaching, so it can also be a big loss and the impact in water quality. But the effect here is similar to other fertilizer. So if you use it at the right time and at the right rate, normally you don't increase nitrate leaching with digestate compared to other fertilizer. But to do that, to use it when at the right rate and time, some good effluent storage capacity and spreading area are needed to allow the application of digestate at the good time. Yeah. And another effect of anaerobic biogas plant also often, at least in France, promote the use of cover crop, energy cover crop to feed the biogas plant. And so in that case, when farmers use this cover crop, cultivate this cover crop, it can help to decrease nitrate leaching compared to bare soil, of course, but even compared to non-harvested and non-fertilized catch crop, some authors suggest a similar efficiency to limit nitrate leaching. Yeah. So concerning nitrate leaching, normally it shouldn't be a big issue. Yeah. Just briefly, Digestate also brings some phosphorus to soil, and in this Digestate, even if it's an organic fertilizer, like the other fertilizer, the phosphorus in Digestate is mainly present as inorganic phosphorus, but its availability depends on the type of mineral form of phosphorus and the pH of digestate and also the pH of the soil. So it's a bit complex, but usually it is considered as an efficient P fertilizer. So yeah, you have some example of mineral fertilizer equivalent of for phosphorus of digestate. You can see it's almost 100% like big slurry, much higher than the phosphorus value of green waste compost, for example. Okay, so now some effect on soil physical quality. There are limited and contrasted results in the literature, and some studies suggest very limited effect of digestate application. But here, just show you an example of a study that show a significant effect. So you have two digestate in blue and green compared to a compost in gray and to a mineral nitrogen in orange, and you have a change in soil aggregate stability or a change in water infiltration. And so this author show a strong increase in these soil properties. But again, there are limited results in the literature, and some of the studies show limited effect. And it's not just typical of digestate, but it's globally related to organic fertilizer. Some long-term effects are expected in the long term after repeated application, but usually you need to use high rates of organic fertilizer to have some effect in the long term. And also it's often not sufficient to strongly improve soil physical quality. The application of organic fertilizer, digestate or other. Sometimes a concern with digestate is also soil compaction. So when the farmers has already slurry, it's not really different because he used to apply slurry with a slurry tanker, and now he has digestate, so it's not necessarily different. But the repeated digestate application and unsealing of biomass to feed the biogas plant can also increase the risk of soil compaction with a possible yield loss. So here you have a figure showing the soil penetration resistance after slurry traffic. So it's not for digestate, it's for slurry, but it's the same. So in moist condition, you have a risk of soil compaction. So to avoid that, it's there is the interest of umbilicant spreading. So it's like on this photo at the bottom. So the slurry, the tank of slurry is not in the field, and you have a long pipe that bring the slurry to the spreader. But it's not always feasible, especially when you have small fields or isolated fields. Of course, also to avoid application in moist condition, and also to adapt a good tire pressure and control traffic farming are also promoted by some authors. So this means that you have always the same, you have some permanent traffic lane in your field, so that the compaction is limited to the same, to a limited area of your field. Yeah? In terms of soil biology, so like soil physical quality, but maybe there are more studies, but there are still limited study, and there are contrasting effects depending on the type of digestate, also to what you compare digestate. So if you compare to inorganic fertilization or undigested biomass, or to non-fertilized control. But globally, there are less, since you have labile organic matter has been digested, there are less stimulating effect on the soil biology and raw biomass. But globally, it seems that digestate application, there is not an alert of digestate on their effect on soil biology, but neither an alert nor a big interest to improve soil biology. Yeah? So here just an example of one of his review site of Karimi that show that in approximately half of the case, when digestate are compared to other organic fertilizer, there is no difference in terms of soil biology. A part of studies in grid show an improvement, and a part show a decrease in soil biology quality. Just a short focus on earthworm and the effect of earthworm, because there are also some concern about this topic. So it is shown that it has been shown that a digestate application can have some temporary toxic effect on earthworm, with some lethality observed just after application. Apparently, it could be related to the ammonia content of digestate. But it is also good to know that some study are also some published result about slurry. So it's not only for digestate, this toxicity. And this study, cited by Mana, show that even if there is a short-term toxic effect of digestate, in the long term there is a positive effect on earthworm abundance. So you can see on this figure the increase in earthworm abundance with digestate or either raw or with a fast separation. It's a 2 bar on the right compared to a mineral fertilization. It's on the left. It's approximately the same with undigested manure, the second bar. An interest of digestion can be also the decrease in weed seeds in the manure, because these manure are often contaminated with weed seeds. So it's anaerobic digestion is efficient to suppress the germinative potential of most weed seeds, especially thermophilic, so at high temperature of anaerobic digestion, even if it's not more frequent of biogas plant. Mesophilic are more frequent, but mesophilic has also an efficiency to decrease this germinative potential, but it's less efficient than composting because the temperature is lower in a biogas plant and during composting. But it can be an interest of digestion also. And finally, in terms of soil quality, there are also some concern on soil contamination. So it's what when you analyze some digestate, you can find some trace metals, some polycyclic aromatic hydrocarbons, some PFAS, pharmaceutical, pathogen, microplastics, or whatever you want. And the content of this contaminant depends a lot of digestate waste. So as you can guess, so usually much less contaminant in manure than in sludge, for example, or urban waste. And globally, the waste not issue from selective sorting are more contaminated here. And it's a bit hard to have to make a summary of all the study about contamination, because there are very different characteristic in terms of persistence, mobility, and toxicity of these different contaminants. But at the moment, most of the studies show limited transfer to this contaminant to crops. There are still some issue also to assess the ecotoxicological effect on soil fauna, for example. But all these issues are not specific to digestate. It's similar to undigested biomass. Yeah? So it can be an issue, true, but it's not finally specific to digestate. Yeah? And just to finish, so I have. I was asked to speak about digestate, so my presentation was focused on that. But usually when farmers set up a biogas plant, there are other change than just the use of digestate in their farm. So different change can happen with different models. And so some example of change observed after biogas plant setup is a modification of crop rotation to allow the insertion of more energy cover crop in a double crop system. Also the modification of grassland management or in the use of fertilizer, pesticide, irrigation, modification of the livestock feed, and increase or decrease of the herd size. So there can be very different change caused directly or indirectly by a biogas plant, and all this change have a expected effect higher than the application of Digestate, in fact. Just to show a short example, the crop area of a farm before to set up a biogas plant and after. So you can see here that a part of a grazed grassland was replaced by maize to feed the biogas plant. So it is sure that this change at the farm scale will have more impact on soil than the application of digestate instead of undigested manure. So as a conclusion, digestate are globally some good, efficient nitrogen and P fertilizer, but to keep this good potential, it is important to limit nitrogen losses, especially ammonia, with good practices. The digestate application contribute to soil organic matter like whole over input of carbon to soil. But and thanks to because even if there are some export of carbon in the biogas plant, there are still some residual carbon in the digestate, and its stability is higher. But when you make a balance, usually you have a slight decrease of soil organic carbon stock compared to the application of undigested biomass, except if you have some import of carbon in your biogas plant, which is often the case here. Real life. Digestate can affect soil physical and biological properties, but it is often limited. So it's not, at least it's not sufficient to improve soil quality alone. Yeah. But it's not also a big threat to soil. And the effect of a system change caused by the development of anaerobic digestion may be higher than those of digestate application alone. Yeah? And just to finish, I put here at the end of this slide a link to a website that was developed in the Fertidig project, where you can find a lot of information on digestate and fertilization with digestate, but it's in French, yeah, so only for French speaker person. So thank you very much, and if you have any question, don't hesitate.
Thank you for your presentation and all these results. There is currently no question, but I have some question. Your presentation make me think about a conference on this subject in 2019 from one of your colleagues. There is a lot of new data presented today. I note from your presentation that digestates are neither a problem nor a miracle in the agriculture, and that the condition under which they are used and the change associated with biogas production can have a greater impact than the spreading of digestate on the soil. That digestates have their own characteristic, which vary according to the input and treatments used on the biogas plant, and which need to be understood in order to use the digestate in the best way possible. So I have a question. In 2019, your colleague talked about a long-term experiment in digestate spreading on soil, and she compared also with the experiment you have on compost. Do you still have this long-term experiment on digestates?
if we still have this long-term experiment?
Yes.
Is the question? Yes. So at the moment, it's not a very long term because this experiment started in 2017. So I guess it's it's a NUSI experiment. Meta. Yeah, it's the result on earthworm come from this experiment. So typically in this experiment we compare, and it's also for ammonia. Yeah. It's the experiment where we have 4 treatments, one with mineral nitrogen application, one with raw slurry and manure application, one with raw digestate, and one with that use both solid and liquid digestate after fast separation. So this experiment is still ongoing. So it is used a lot at the moment in France when we want some result about the effect of digestate on soil physical quality, for example, or soil biology. At the moment, it's still a bit young to have some clear effect on soil organic matter. Yeah. So it is sure that most of the results I show you are based on modeling study because there are not so many long-term experiments with digestate.
Okay, but the experiment you plan to maintain it over time?
Yeah. Normally it will be maintained in the next year, and so I hope we could see a clear effect on soil organic matter in the long term to confirm what modeling study indicate. And also a small issue with this experiment is the soil was a bit was not very homogeneous in the field, so we will need to wait a bit longer to see some clear effect on soil organic matter, yeah, because of the heterogeneous soil of the experiment.
Okay, so I was a question, but let's take the first one on the chat. So the first one is, does the effect on soil biology vary depending on the origin of the digestate, organic waste? Sieve is I don't remember in English. Energy cultures or manure.
So I'm not expert at all in soil biology, so I will have some difficulties to answer clearly this question, but more globally, not only from digestate, but globally for organic fertilizer, it is sure that it has some, depending on the type of organic fertilizer and amendment, it has different effect on soil biology, and depending also on which type of indicator you are looking at. If you look at enzymatic activities, microbial biomass abundance or diversity, and so on. So the effect depends a lot on the type of indicators and also on the type of organic input. So for digestate, it surely will be the same. But as I have no clear result in mind to share. But I think in the tool review I have cited, there are some elements on that. And this check.
There is a question: have these data been published? I think it's about only study you present.
Yeah, most of them. Yeah, just to on soil biology. Yeah, the two Karimi and Van Meeden. It's two recent review on the effect of digestate and soil biology. I think Karimi is mainly on microbial biomass, and Van Meeden is broader. So I think you have some element in these two. And yeah, when I have put some source in gray, you have the link at the end of a presentation. Yeah. You have a list of reference at the end that can be shared. Yeah.
Do you have data about soil compaction due to repeated digestate application? To complete the question, is there a difference between the application of digestate and the application of manure or slurry?
Yeah, there is no. Yeah, it's the same in terms of soil compaction. If you apply slurry or digestate, it mainly depends on loads of the machinery and the condition when you apply it. So I think for livestock farmers, it's not a big difference. But for example, I work a lot with farmers in cereal farms that have set up biogas plants. So for them, they replace mineral fertilizer application with digestate application. So the load of the machinery is much higher with digestate than with mineral nitrogen. And moreover, since they introduce energy cover crop, there are some repeated hand-seeding operation in their field. So it can cause a soil compaction, compared to what were before the biogas plant setup. Yeah.
Okay. There is a question about can we get a presentation? Yes, the presentation and the replay will be available on the YouTube page. I will give you the link on the chat at the end. I have another question. You saw in the slide 17 a decrease in carbon storage with Digestate. Is this fact described in other studies? Because it's quite new for me to have a decrease in carbon storage with Digestate.
It's a slight decrease. Yeah, it's so. For example, here you have. That's why I say stable to slight decrease. If you take the oldest study, for example, the one on Thomson, they say it's almost stable. You can see when you compare the figure, it's a bit lower with digestion compared to raw biomass when you apply raw biomass to soil. But the other studies right here show us, a small decrease in soil organic matter. Because even if you increase the stability of digestate compared to undigested biomass, it doesn't compensate the loss of carbon in your biogas plant. But it's a bit theoretical for me because in most biogas plant, farmers introduce more biomass. So either external waste, or they start to produce more cover crop to feed the biogas plant. So at the end, I think in most cases it results in an increase in soil organic matter, not because of digestion, but because of more biomass, in the system.
Okay. And for you, are there any new specific study to be conducted on Digestate, on new topics, with no results at the moment?
There is a need for more study because it's still, at least in France, it's sure that in Germany it's already an old topic. But I think the systems are not the same, and the feedstock of a biogas plant are not the same. So I think there is a need for more study on the effect of digestate on soil. So it's still a research topic in many areas, either physical properties, biological, and so on. And and also a big topic. It's on what I finished. It's not directly on the effect of digestate, but it's more globally in the system change caused by the development of anaerobic digestion.
Okay. So no new question. I have a last one. For farmers, for you, what would be the main recommendation on the use of Digestate, if there is one?
It's not an easy question. It is true that, like for raw manure, to have enough storage capacity and spreading area to use it really at a good rate and time. I think it's very important to optimize the nitrogen use efficiency of the digestate. So I think it's very an important topic. also to spread it when, so it's easy to say, not easy to do maybe, but also to avoid the application in bad condition, for example, in terms of soil moisture, or also in terms of weather, if it's too hot, because it can promote volatilization. So, yeah. But I know that it's theory, and in the real world of farmers, it's not always easy to apply these good practices. Yeah.
Okay, thank you. So there is no new question, I think. I will give you the link for the presentation on the YouTube. You can find the previous presentation, and this one will be available in a few days. A question from Florent. Do you have different results or experience in other countries?
Yeah. In this presentation, I have cited a lot of work made in INRAE in France, but also some work made in other countries. So it's not specific to France situation, but it is sure that at the moment the three main biogas producers in Europe are Germany, Italy, and France, I think. So there are a lot of studies published from these three countries.
Okay, so thank you. Last one. Yes. So after this presentation, we have a satisfaction poll. So maybe Susanna, you can give it. Yes. So there's 3 questions. So please answer them. And for the last one, for some ideas on next webinar. For example, it can be the impact on reducing greenhouse gas emission from dairy farms or other farms with biogas production, and the link with carbon credit rewards. It can be the I'll make some lists. The acceptance of biogas plant in farms, competition with this boundary for fodder, industrial byproducts, technological solution, byproducts, carbon dioxide, for example. Biogas as fuel, data monitoring of biogas plants, natural gas network solutions, environmental evaluation of biogas plants. Some examples, if you want. And for the third question, it will be information for us to organize the next webinar, to have ideas of what you're interested in. If you don't have ideas now, but if you have ideas later, you can send us the ideas. Okay, maybe we can can end the poll and finish the webinar. Still some people. Okay, maybe Susanna, you can end the poll. And now I have to thank all of you for coming to this webinar, and Florent for this very interesting presentation. So thank all of you, and have a good day.
Thank you for the invitation.